system here on this Corolla here. You can see over here, this is your inlet hose for your fuel injector fuel rail. Comes in here, and your fuel injectors are located underneath this heat shield. 4 of them, 1 for each cylinder. It's a port fuel injection system, so it injects your fuel prior to the intake valve. And this is a returnless system, as you can see, because there is no line going back into the fuel tank after the fuel reaches the engine.
Alright, so on this 2009 Toyota Corolla, we just did a resistance test on all the fuel injectors. This test is super easy. All you need to do is disconnect the cap, make sure your test leads are on both probes and aren't connecting. And then if you come here, you can see we're running 12 volts or 12 ohms of resistance. We went through all these injectors. 12 to 12.1 was what they all were, which is right in spec, so our resistance is good on the fuel injectors. Okay, so as you can see here, we're doing a voltage drop test on the fuel injector. At idle, we're dropping about 0.6 volts, and as we rev the engine up, we're dropping about 1.2 to 1.3 volts. So here we have a picoscope hooked up to our fuel injector, and not only can we see how long the fuel injector is open for, but we can also see how frequently they are opened. So what we have here is a snapshot of the fuel injector firing. As you can see on the left side, we have a consistent voltage, nothing's going on, we're not powering the coil. When the computer tells the coil or the fuel injector to fire, we power the coil, our voltage drops. Then we use consistent voltage then to hold that fuel injector open, which is that flat line. And then once we have injected the amount of fuel into the cylinder we need, we close the coil, causing a voltage spike and then flatlining back to normal. And all that happens in this instance for 3.2 milliseconds. So after figuring out that, just as a general basis, that a fuel injector for this car at idle is about 3.2 milliseconds, we then started to tweak and play with different sensors to see if we can change how long that fuel injector is actually open. And one of the things we did was cause a vacuum leak after the MAF sensor, so the car was unaware of how much air was actually being added to the system. Once the exhaust gas got to the O2 sensor, it was reading that the car was very lean due to the vacuum leak and excess air into the cylinder, causing the fuel injectors then to be opened longer.